Spoiler alert, we are working our way up to being able to calculate instantaneous rates of change. In some of these examples, I've pointed out the fact that the rate of change is not constant, and that in fact, the average rate of change doesn't necessarily reflect everything that happened over that period. Think of our temperature example. We found that the average rate of change in temperature with respect to time was -1 degrees Fahrenheit per hour, but that doesn't mean the temperature was constantly dropping. The precise rate at which something is changing at a moment in time or a specific input value is called the instantaneous rate of change. One concrete example of this is the speed of a vehicle. If someone makes a 250-mile trip in 4 hours, we can calculate that their average speed was 250 miles divided by 4 hours, which is 62.5 miles per hour. This is the average rate of change. But their instantaneous speed at any moment during the trip is what their speedometer was showing at that time. More than likely, at times they were driving slower than 62.5 miles per hour, and other times they were driving faster than 62.5 miles per hour. So the instantaneous rate of change in their distance traveled over time varies over the course of the trip. Fun fact though, we can guarantee that they were traveling at exactly 62.5 miles per hour at least once during the trip. We'll learn about this later when we talk about the mean value theorem for derivatives. For now, we will approximate instantaneous rates of change using average rates of change over shorter and shorter intervals, leading to the idea of a limit.